Hello, I am Vijay Kumar. In this video, we are going to discuss about reflection of light, laws of reflection, formation of image formed by the plane mirror. Only few surfaces can form image, but not all the surfaces. And the characteristics of image. If you did not watch my first video, I suggest you all please watch my first video and come here. The link is given below. To understand reflection of light easily, let us consider a carom board. Let's say the coin is here. Now I need to strike this coin, but this way is not allowed. So what I should do? Generally taking reverse. Okay, I strike it here and expecting to reach the strike here, but striker disappointed me by taking its own path. This is the path of the striker and this is the direction of the striker. Similarly here, this way of representation is called ray, path and direction. Generally, we use this ray to represent the light. Okay, now no problem. One more try. I strike it here and again striker disappointed me by choosing this path. What striker is doing? The striker is just bouncing from this surface. If we observe carefully, we can understand one thing. See, at this point, it is bouncing. So, if I draw a perpendicular line and see, this angle and this angle are same. Similarly, at this point, the striker is striking. So, if I draw a perpendicular line, see, this angle and this angle. So, we can clearly understand when a bouncing occurs, at what angle it strikes. With the same angle, it bounces back. Similarly, light also bounces from all the surfaces. So, can we apply it to the light? Yes. This is the mirror. This is the light. Light is incidenting, so this is called incident ray, and at this point light is incidenting, then we call it is point of incidence. And this is the perpendicular line. We call it is normal line, normal, and this is the bouncing light. This light is called reflected light or reflected ray, right? This is at angle which incidents, so we call it is angle of incidence, and this angle will be angle of reflection. And we have seen that angle of angle of incidence equals to angle of reflection. Now you are able to define reflection of light. What is reflection of light? Bouncing of light from the surfaces. Actually, light bounces from all the surfaces, but only few surfaces can form image, but not all the surfaces. Yes, here is the answer. Let us say, we have a candle. Light travels in all directions from the candle. We have a plane mirror here. So, the rays which are falling on the plane mirror gets reflected. These are the reflector rays. And if we see clearly, these rays seems to be coming from a particular point. But these rays are actually coming from this point. We call it as an object. but these rays seems to be coming from this point called I. So this object again appears at I. This is we call image. So if you see these rays seems to be coming from this point, so we can see image at this point. Now let us see here the same thing, candle and a surface, but this surface is irregular surface, not like a soft. So light falls on this and gets reflected, and this is one more reflected, this is one more. Here the black lines are normal lines, and again here also it is following the same rule, angle of incidence equals to angle of reflection. And see, this angle and this angle are same, this angle and this angle are same. So if you see these rays are seems to be coming from some particular point. No, these rays are seems to be coming from the surface. So we can see the surface, not the image. So from this you clearly understand, highly polished surfaces can form image, but not all the surfaces. The best example for this is water. Water in steady state can form image. Even a little disturbance can spoil the image. This is how image formed by the plane mirror. But have you ever seen this type of ray diagram in the textbook? This is called a ray diagram. But we haven't seen the ray diagram. You can see this type of ray diagrams in the textbook. Those are now, is this a correct ray diagram? Yes. See, we will take a point object at O. The image forms at I. Again same. But we can consider only two rays, because two rays are enough to show point of image. Because where the two rays are intersecting, the remaining all other rays also will intersect at the same point. So to represent the ray diagram, two rays are enough. This way of representation is called ray diagram. Laws of reflection. Just now we have seen that angle I equals to angle R. So this is the first law of reflection. And we have second law too. That second law is, see, if you throw a ball, the ball bounces and go like this. Have you ever seen, not in the cricket, have you ever seen if the ball falls here and reflected like this? Or if a ball falls here and reflected like this? No, the ball falls here and goes like this. So if you see, this is incident, this is reflected, and this is the normal. They all lie in a same plane. The best example for the plane is a paper. So incident ray, normal, and lie in a same plane. If this is the mirror, let's say an object is here, an extended object. So I am considering this is a point A, this is point B, this is point C. So if I draw the reflector rays, you can take any two rays. If you see all these rays, if you take a point A, this point A forms image at here. So we call it is A dash. Point B forms image at B dash. Point C forms image at C dash. So this is the image and these are not rays, these are the extended rays to get the point of intersection. So these are the rays. A light ray is incident and reflected back. A light ray is incident and reflected back. Wherever you take, if you draw a normal line, this angle and this angle will be equal. So if you check here, see, wherever you check. So this type of image we call erect image. So this is the object. Image is also forming in the same way. We call it is erect. See, if the object is like this, if image is like this, then we call it as inverted. So what is erect? Which is not inverted, as it is. If the object is like this, image should also form like this. And image, if this is the object, the image size also same. So we can say same size. And these are not actually rays are intersecting. These rays we extended them back to intersect. So this type of image is called virtual image. We will describe about virtual image and real image in the spherical mirrors. And we can notice that this distance, let's say D, and this distance also we will find that D. So image forms at the same distance. You might have noticed that the image formed by the plane mirror shows lateral inversion. What is lateral inversion? Left is right, right is left. Right. Yeah, let us see. If this is the mirror, then this is an object. Let's say if I place an object like this, image is also forming like this. If I place the object like this, image also forms like this. If I place the object like this, image also will show this. If the object is this side, image will show this side. But where is the lateral inversion is occurring? Yeah. If I place the object like this, image will show you like this. So what mirror is doing? It is just reflecting you exactly how a person is talking face to face each other. Exactly you and me. If this is right side for me, this will be left side for you. This is what lateral inversion. If you really like it, share it to your friends.